Welcome to chapter of our course on operating systems and networks. In this chapter, we will delve into the fascinating world of operating systems and explore their role in managing computer resources and enabling efficient computing. Today, we will start with an overview of operating systems, understanding what they are, their functions and features, as well as the different types of operating systems. Let's get started. What is an operating system? An operating system, or OS, is a software program that acts as an intermediary between the user and the computer hardware. It serves as a bridge that enables users to interact with the computer system and utilizes the underlying hardware resources efficiently. The operating system manages and controls various aspects of the computer system, such as memory, processes, files, and input-output devices. It provides a platform for running applications and executing tasks, making it an integral part of any computing environment. Functions of operating systems. Operating systems perform a wide range of functions to ensure smooth and efficient operation of the computer system. Let's explore some of the key functions of operating systems. One important function is process management, which involves scheduling, creating, and terminating processes. The operating system decides which processes to run and allocates resources to them, ensuring fair and efficient utilization of the CPU. Another crucial function is memory management, where the operating system is responsible for allocating and managing memory resources. It keeps track of available memory and assigns portions to running processes, optimizing memory usage and preventing conflicts. The operating system also manages the file system, which involves organizing and accessing files and directories. It provides an interface for creating, modifying, and deleting files, as well as for navigating and searching the file system. Furthermore, the operating system handles device management, which includes managing input/output devices, such as keyboards, mice, printers, and disks. It provides mechanisms for device communication, ensuring proper utilization and coordination of these devices. The user interface is another essential function of the operating system. It provides a means for users to interact with the system, whether through a graphical user interface, GUI, or a command line interface, CLI, allowing users to run programs, access files, and configure system settings. Lastly, the operating system ensures security and protection of the system and user data. It implements measures to prevent unauthorized access, protect against malicious software, and maintain the integrity and confidentiality of information. Features of operating systems. Operating systems offer various features that contribute to their functionality and efficiency. Let's explore some of these features. One important feature is multitasking, which allows the operating system to execute multiple tasks concurrently. It switches between tasks rapidly, giving the illusion of simultaneous execution and enabling efficient utilization of system resources. Memory protection is another critical feature. The operating system ensures that processes cannot access or modify memory areas allocated to other processes, preventing unwanted interference and maintaining system stability. Virtual memory is a feature that allows the operating system to use disk space as an extension of physical memory. It enables efficient memory management by swapping data between physical memory and disk, effectively expanding the available memory for running applications. The file system is a vital component of the operating system, providing a structured organization and management of files and directories. It allows users to store, retrieve, and manage their data, providing a hierarchical structure for easy navigation and access. Device drivers are software components that enable the operating system to communicate with hardware devices. They provide an interface for the operating system to control and interact with devices such as printers, scanners, and network adapters. Types of operating systems. Operating systems can be categorized into several types based on their design principles and areas of application. Let's explore some of the common types of operating systems. Single user, single tasking. This type of operating system is designed to support the single user and allows the execution of only one task at a time. Examples include early versions of MS-DOS, single-user multitasking. This type of operating system allows a single user to run multiple tasks simultaneously, leveraging multitasking capabilities. Examples include Windows, macOS, and Linux. Multi-user. In a multi-user operating system, multiple users can access and utilize the system resources concurrently. Each user has their own user account and can run multiple processes simultaneously. Examples include Unix and modern server operating systems. Real-time. Real-time operating systems are designed to handle time-sensitive applications where response time is critical. They guarantee timely execution of tasks and are used in industries such as aerospace, industrial automation, and medical systems. Embedded. Embedded operating systems are designed for specific embedded devices with limited resources, such as smartphones, tablets, and IoT devices. They are optimized for efficiency and provide features tailored to the device's requirements. Network. Network operating systems are designed to facilitate network communication and resource sharing among multiple computers. They enable file and printer sharing, centralized administration, and user authentication across a network. Each type of operating system has its own characteristics and is designed to meet specific needs in various computing environments. In this overview of operating systems, we have explored what operating systems are, their functions and features, and the different types of operating systems. Operating systems are essential components of computer systems, providing a layer of abstraction and efficient resource management. Understanding the role and functionality of operating systems is crucial for computer science and IT professionals. Thank you for joining us in this chapter on operating systems. In the next session, we will dive deeper into the concepts of processes and threads. Stay tuned and keep exploring the world of operating systems and networks. If you found this lecture on operating systems informative and helpful, we encourage you to like this video and share it with others who may benefit from it. Don't forget to subscribe to our channel to receive notifications about future lectures and updates. Thank you for your support.